Hello everybody and welcome to the video on absolute value, and I'm going to be reminding you about the definition of absolute value. But first, what I'd like you to think about is from your past classes, when you hear the phrase absolute value, what comes to your mind first? Well, some of you might automatically be saying, well, I'm going to get a positive number. Some of you might have said, well, I remember the symbolism for absolute value, something like the absolute value of x, or the absolute value of positive 3, or absolute value of negative 4, or even something with more variables, the absolute value of 2x minus 4. All of these are within the absolute value bars, and yes, absolute value does mean that you would get a positive number out when you plug them in the bars. So if I plugged any value in for x, the answer would come out positive. The absolute value of 3 would be 3. The absolute value of negative 4 would be positive 4. The absolute value of 2x minus 4 would come out as a positive number. I can't say necessarily it would come out as 2x minus 4 because I don't know what x is yet. But I do agree that absolute value does come out as a positive number, but that's not technically the definition of absolute value. The definition of absolute value is the distance between the origin and a number. So, for instance, if I drew a number line from negative infinity to positive infinity, and I have 0 here in the middle as a placeholder, and let's say that I'm talking about the distance of 2. What absolute value means is that the distance from the origin to positive 2 and the distance from the origin to negative 2 should be the same. So in this case, the distance from 0 to 2 is positive 2, and 0 to negative 2 is also positive 2. What I want you to recognize is that distance is always going to be a positive entity. Picture taking out a yardstick or a ruler and measuring these distances. If you're going from 0 to 2 and you lay down a ruler, that distance is a positive 2. Even though here I'm going in a negative direction, like getting pushed back in football, if I actually measured that actual distance with a ruler, it would still be a positive thing, which is why distance is always a positive entity. Now, something else I want to point out at this time is that not only when I look at this distance do I view a positive number, I also view a change in the numbers. It's kind of somewhat of a synonym. And I also think about the math term difference. The difference or the subtraction of two quantities is going to get me a distance or a change, kind of like a slope, like a rate of change. I always subtract to find that distance or difference in the numbers. So all of these words are going to help us. So absolute value is always positive and represents a distance from 0 to a particular number. So let's use this definition to look at this first problem. The temperature in Chicago was a certain value last night at midnight, and then 87 degrees at noon today. Write an equation to represent the change, there's that word I was just talking about, in temperature over the 12-hour period. So we want to write an equation or an expression, I think specifically an equation in this case, that might use absolute value. So first, we know that the temperature was a certain value last night. And to me, that means I don't know what that is, so I'm going to call that x. I also know that I need an equation, so I'm going to have an equal sign somewhere. And we want to write an equation that represents the change. Now, as we just discussed on the last slide, whenever I think of the word change, it's really a difference or a distance, which really leads back to absolute value. So I know I'm going to have absolute value in this problem. If I want, and not only am I thinking that change leads to absolute value, I also think of change as a difference or subtraction. So if I subtract where the temperature is last night from where it is at noon today, the temperature was minus where it is now, then I know that's going to represent my change or my absolute value. But here's the real reason I need an absolute value. Let's talk about situations. Let's say that x, the night before, or last night at midnight, it was 90 degrees. The change, 90 minus 87, would give me a 3-degree change. However, if the temperature last night was something like x equals 85 degrees, that change would be -2 degrees. But because I know that change has to do with absolute value, this 2 has to really be a positive. So to make that 2 positive, I have to put absolute value bars around x minus 87 to make sure that my answer is always positive. So that expression, the absolute value of x minus 87 equals the change, would be my answer. The next example, the distance, again, I'm going to underline that because that leads me directly to think absolute value or difference or change between x and 10 is at least 6. And when I see this phrase at least, I'm thinking 6 or more, or 6 or larger. So if you think back to your algebra days, we usually use an inequality in this case to represent that situation. If it's 6 or more and 6 is included, we could use greater than or equal to. And so what we would like to do in this problem is to write in an inequality, an equation, something to describe what the situation is going on. Distance, the distance between x and 10. So if I know it's a distance, I know I'm subtracting. So we could do x minus -10 is greater than or equal to 6. However, we're missing something. Distance always has to be positive, and I don't know if this x is a positive or a negative number, so I need absolute value bars around everything to make sure that my answer comes out positive. To simplify this a little more, let's change that to a big old plus and make it the absolute value of x plus 10 is greater than or equal to 6. Now, I assumed that the problem went in the order that I read it, the distance between x and -10. But we could say that -10 comes first. So I'd like you to pause the video and write a possible second answer that could be true if you switch the order of the -10 and x. So please pause now, and I'll come back with my answer. In green here is my possible other solution. If -10 comes first, you're still saying a difference or a distance, so you'd say -10 minus x is still greater than or equal to 6. And because, again, I don't know what x is, I need to make sure my answer becomes out positive because distance is always a positive thing, so I know I need absolute value bars. Either answer would be accepted on a test. Last example here, let a be any real number. And again, what that means is that's what the first video was about. Real numbers are natural numbers, whole numbers, integers, rational numbers, irrational numbers, really anything but imaginary numbers. So we want to try to explain how it could be true that this is a possibility. We want to see, is there any examples that could prove that the absolute value of a is equal to the opposite of a or negative a? So what I want you to do is pause the video and think about what number or types of numbers could make this equation true. And if you're feeling really exquisite, you could even find an example that is not true or could poke a hole in this argument. So please pause now and think about what is true and what could cause this to be false. So as you were thinking, here's some things that I came up with. I came up with a few situations that work. For instance, if a is exactly 0, and I plug 0 into the situation, the absolute value of 0, or the distance from 0 to 0, is 0, and negative, or the opposite of 0, is also 0, so I get a true statement of 0 equals 0, so I know that if a happens to be 0, this situation works. If a is a negative real number, so -2 is a possibility, -1/2, -√3, this is irrational, but still real. If I plug any of these in and check them, the absolute value of -2, the distance from 0 to 2 is 2, and the opposite of -2 is also +2, so this works. If I tried √3, the absolute value or the distance from 0 to √3 is a positive √3, distance is always positive. The opposite, or the negative √3 is also positive, so any negative number will work. However, the situation that does not work is if you have a positive real number, like a equals 5. If you plug 5 into the situation, the distance from 0 to 5 is just positive 5, but the opposite of 5 is negative 5, and 5 equals negative 5 is definitely not a true statement. So because this is not true, this does not work. So these are my only possibilities that are true in green and blue. All right, guys, that's the end of the absolute value video. Thank you for sticking with me. If you have any questions, please let me know tomorrow in class. Thanks.